In this video, we'll look at the three core properties of all physical bodies in Corona SDK. As mentioned in the video on creating simple physics bodies, Corona SDK has a built-in physics engine which lets you turn any Corona display object into a simulated physical object. All physical bodies in Corona are created with the physics.addBody function, which accepts an object and a table of properties as its parameters. All physical bodies possess three core properties: density, bounce, and friction. Each can be defined as a key value pair in the properties table. These properties are optional and their default values will apply unless otherwise specified. All physical objects have a default density value of 1.0. This parameter is based on a standard value of 1.0 for water. So materials that are lighter than water, such as wood, have a density less than 1.0, and heavier materials, such as stone, have a density greater than 1.0. You can set density values to whatever feels right for your simulation. In this example, the density of crate 1 is the same as crate 2. If we apply a force to crate 1, it knocks crate 2 off the screen. If we change the density of crate 2 to 10.0 and apply the same force to crate 1, crate 2 moves only slightly when the two crates collide. The reason for this is that crate 2 has 10 times the density and thus is harder to move. Bounce is the box 2D property known as restitution, and it determines how much of an object's velocity is returned after a collision. Values greater than 0.3 are fairly bouncy, and an object with a bounce value of 1.0 will rebound forever. For example, if the object is dropped to the ground, it will bounce back up approximately the height from which it was dropped. Bounce values higher than 1.0 are valid, and they will actually gain velocity with each collision. In this example, two crates of the same size are dropped from the same height with the same amount of density and friction. Crate 1 is given a bounce of 0.3 and crate 2 is assigned a bounce of 1.0. Crate 1 bounces only slightly while crate 2 continues to bounce forever. Friction may be any non-negative value. A value of 0 means no friction, and a value of 1.0 means fairly strong friction. The default value is 0.3. In this example, if we set the friction of crate 1 to 0.5 and apply a force to it, crate 1 glides across the ground and collides with crate 2. If we increase crate 1's friction to 2.0, we increase the amount of resistance it encounters as it moves along the ground. When we apply the same force as before, we see that crate 1 barely reaches crate 2. For more details on working with physical objects, check the documentation located on the Corona Labs website. And that's a look at the three core properties of all physical bodies in Corona SDK. Learn more about working with Corona SDK at coronalabs.com/university.